Folks, feel free to write yourself some notes or correct. So this is, I know it's not just like the ones we've been doing where you would say something like G is the antiderivative of F, but it's, geez Louise, it's like 90% overlap. It's really the same kind of ideas at work, whether you talk an integral defined function or you're given the derivative and you want the antiderivative function. It's really a lot of the same thing. So, mostly fundamental theorem. F is increasing on what interval did you say? Let's go, Mr. On. F is increasing on?
-3 to negative.
And why do you say that?
Because that comes down.
All right, perfect. That is absolutely correct. B, find the x-coordinate of each point of inflection. Where do you go looking for inflection point? Let's start with the big idea. Inflection point where? Okay, let's start with the big idea of calculus. Inflection point is where the second derivative changes sign. Okay, and then let's work towards what they're giving us. So, f prime, which equals the derivative graph slope, changes sign at, and where did you say it changes sign? At x equals 0 and 2. Okay? Again, in all cases, you can answer first and then give the justification or say this is where I looked and this is my answer. So those two components could easily be switched. Say what? The y? This is the y. Oh, normally yes, but good point. That would be considerable more work, but they only ask for the x. You're right. I didn't even actually look. I just assumed. Good question. Okay. C, find the equation of the tangent line. What are the three parts to doing a tangent line problem? The point, slope, and then point slope. So what's the point? 0, 3. That's given. The slope. You need to communicate where you're finding the slope. You can't just say m equals. You need to make the calculus conclusion. Where do you extract the slope from? F prime at 0. You need to communicate, I use the derivative to get the slope. And that is that the slope of the graph, or is it just the y value of the graph? Yeah, so it's just -2, and therefore your tangent line and point slope form would be something like y minus 3 equals -2 times x itself, or x minus 0 if you like. You wouldn't have to write that minus 0 if you didn't want to. You with me? Okay. Last but not least, f at -3 and f at 4. This requires fundamental theorem. You're taking the area under f prime, which is a definite integral, relating it to what you're given and what you want, and then rearranging a little. Now you're given f at 0, okay? So in this case, should I go 0 to -3, or should I go -3 to 0? I really feel this is safer because you're going left to right. It's not this negative dx-y kind of issue. This you'll see is much safer. Now, by fundamental theorem, isn't that the antiderivative, which is f, at the upper minus the lower, right? So if I rearrange that to isolate what I want, f at -3 is f at 0 take back the area under the curve. We? All right, f at 0 is given to be 3 minus, oh, now I understand what your question was. You said distributing, yes, it should have been in parentheses. I answered that question better. All right, so it needs to be opposite of the area under the curve here. Now, that area is actually two areas. One positive rectangle, because it's above the curve, and therefore the height is positive f, and so to be positive, but the lower one are negative f values, so it would give you negative. So you need to be careful about signs of the two different regions and distributing the negative. The first region, what's the area of that? 1 by 1 over 2, so 1/2. The next region, 2 by, is it 3 by 2 by 2 over 2? Okay? So maybe something like 3 minus negative 3 halves. Do you agree? And so 4 1/2 or 9 halves. How'd you do? Effort 4 was a little cleaner because you're going left to right naturally. So F prime integrated from 0 to 4 would give you F at 4 minus F at 0. F at 4, when you rearrange it, is F at 0 plus the integral or the change or the area under the curve. That is, what is that again? 3 plus. Okay, now this one's a great gotcha. We'll see if you got it. How do you find the area? Is it pi r squared over 2? It is not pi r squared over 2. It is, it's this region.
Minus.
And it's negative. Okay, so there's actually a lot going on for F at 4. It's a negative because it's area below the curve. And let's talk how to find that shaded area. Wouldn't it be rectangle take away semicircle? See? Think of it like taking this area, removing that semicircle to get the shape. So what is the base and height of that rectangle? 4 by 2? Okay. So 3 minus 4 by 2 minus pi times 2 squared over 2. It's 3 minus 8 minus 2 pi. Did you win? Did you get negative 5 plus 2 pi? That's it. That one had a bit of a gotcha component to the G. Okay. All right. Are you getting headway made? Are you making headway? Cool. Let's talk the lesson today. It's very straightforward. You'll find it easy as long as you don't make it too easy. Hey, by the way, this is our period. If you have pins, bring them in, please. Raise your mom's pantry. But tell her you take stuff. I hate it when I go to make dinner and there's not a can of tomatoes, and there should have been a can of tomatoes, right? So, bring something in, please. Unless you're a selfish jerk who can't help anybody else besides yourself. Wow. I'm just saying. All right. Integrals. This is a huge lesson about integral rules. And like I said, the biggest temptation is students kind of oversimplify them, and they think they can do it all mentally, and that usually leads to mistakes on some of the more complicated. So, stick with me and start to get a feel for which ones you can just kind of crank out mentally and which ones you got to be a little more careful. All right, this you should already know. When you integrate a function with a constant in front, you can move that constant out front. We have been using the constant multiple rule for quite a while, so that's not good. Okay? Likewise, we also know that when you integrate a sum, it can be split into separate integrals. Today I'm going to play a little fast and loose with my differentials to get through these, so I will often write these integrals without differentials, which really is bad calculus, but in the interest of time. That is not true for products. Do you agree that I cannot split an integral of a product up into two separate integrals? That's a no. Cannot do that. All right. What do you reckon the definite integral from A to A is? 0. Why would that be true? Let's talk a picture. What does that mean? Here's the F curve. It's the area under the curve from A to A, which is to say it's a rectangle with no base. And that makes sense that that has 0 area. Remember, you're always talking about, in every one of these Riemann sums, it's a rectangle, base, and a height, all the way back to the original concept. All right, this is super duper useful. If you have an integral and you switch the limits of integration, now let's assume originally that A was greater than B, or A was less than B, excuse me. All right, if you switch the limits of integration, by switching these, you're changing x in the opposite way. instead of going left to right, you're going right to left. Well, delta x, instead of being b minus a, is now a minus b. It's opposite. So when you change these limits of integration, you will actually get the exact opposite result of what you would normally have. I guess you could also, I kind of like the visual, but you could also think of this in a fundamental theorem way. You could also say, isn't this f at b minus f at a? Okay? And isn't that the opposite of f at a minus f at b? And isn't that what you would get if you integrated from a to b? Well, that should be capital F, not little f, capital F. Antiderivative is typically. All right. At any rate, if you switch limits of integration, it's the opposite of the normal integral. Cool? Additivity. Imagine you had a region from A to B and then added onto it a region from B to C. Isn't the region from A to B plus the region from B to C equal to the single region from A to C? That's the additivity rule. Also very logical. All these are pretty logical. All right? Let's talk even rod. Now this actually is a hit more in set 86 or something like that, but I can't wait that long. That's ridiculous. If you have an integral from negative a to negative b. Now, I'll tell you that in positive land, a is less than b. All right? Now, on the flip side then, negative a would be closer to the origin and negative b would be further from the origin, right? Now, if you think even, remind yourself that this is symmetric at the y-axis. An even function should have perfect symmetry on either side of the y-axis, like x squared. Therefore, the area from actually, I don't like the way I've written this. Can I switch this? Let's go based off of this picture. Now, these areas should be, despite the fact my picture stinks, they're supposed to be equal. You with me? So let's say that in integral form. The integral from negative b to negative a under f is equal to the integral from b to a or a to b. I'm going left to right in both regions. So negative b to negative a is the same as a to b. Okay? There's symmetry there. Now that's super useful in allowing us to save some time and some integrals. If I have area from negative to positive, I could say it's double the area and use 0 as an endpoint. You'll see this. What does this say? What is this? I don't even, is this in your paper?
Yeah.
What's that about? Oh. I don't like that. Forget that. Okay, let's go here. If you talk about an odd function, try me an odd function like a cube or sine, okay? And let's talk one region from negative b to negative a that has symmetry with a region from a to b. Now surely, because it's odd, the shape of the curve should be exactly the same on both sides, so there should be some kind of correspondence to their areas. But is it straight up equal or the opposite? It's the opposite because you're talking area below a curve. And so you would say something like the area from negative b to negative a is the opposite of the area from a to b. Oh, now I understand what this is for. Can you unscratch this? Got it. Now I understand. What would you know about the region from negative b to be on an even function? It's double the region from 0 to b. Okay. I should have trusted myself and realized I had a point to that. What would you know about an odd function from negative b to b? You've got a perfectly equal area, but one's negative, one's positive. That is 0. Yeah. Now that is wonderful because if you really have your eyes open, you could take a problem like this. Whatever. 3.5 square root of pi. And go tangent of x plus sine of x plus x cubed. And if you have knowledge of this rule, you'd say, oh, that's easy. That's 0 because tangent is odd, sine is odd, and x cubed is odd. And therefore, from a negative region to this positive region of the same would be 0. And you wouldn't have to worry about integrating any of that. All right? Last but not least, also common multiple choices is bounded graphs here. Imagine if I told you some function is greater than or equal to 0. Now, graphically, that would mean it's always above the x-axis. If the graph is always above the x-axis, then what would you know for sure about the integral, which represents the area under the curve? It's positive. Okay? If the curve is positive, the area under that curve must be positive, assuming a is less than b, which we'll say it is. Okay? Likewise, if I had two functions and f is almost always or always greater than or equal to g, so f is always riding above g, even if they're equal at some point, no big deal. Then what would you know about the area under f? If f is always greater, then isn't the height of every rectangle greater? And so the area under f must be greater than or equal to the area under g. All right, and then last but not least, imagine f of x has a lower bound of L. So there's this curve f of x. Here's f. And it has a lower bound, or a lower y value of L, where the curve is always at least as big or greater than L. And it has an upper bound u. So the curve is always less than or equal to u. We're talking a region strictly from A to B. What would you know about the area under F? Bounded below. It would have to be greater than now, let's look at here. Here's the area under F I'm going to do in blue. Yeah? Wouldn't you say if it's always greater than this level L, then it has to be greater than this area under L? What's the area under L? What's the width of the rectangle? It's B minus A. And what's the height? L. Okay? On the upper end, it could not be any greater than the area under the red line, U. Well, what's the area under the red line? B minus A times U. All right. Now, let's see what problems like look like in action here. Say I gave you a fact that the area under a curve from 1 to 5 is 10, and from 2 to 5 is 12. If I asked you to find 10, the area under 1 to 2, now students will typically, no matter how much I say, I want you to write the work, you say, yeah, I'm ignoring you, and I'm going to do the work. And in many cases, it works great. And students are usually successful about 80% of the time, because most of the time, mentally works great. And so you might say, I don't need to do this area from 1 to 5 minus the area from 2 to 5 equals the area from 1 to 2. Mr. Rickman, that's a waste of my time when I know it's just going to be 2 or negative 2. Negative 2. It's 1 to 5 is 10, 2 to 5 is 12. So the answer you're talking about from 1 to 2 is negative 2. That's how it would be done properly. I will, if you do this mentally, I will take it on the homework. But in terms of on the test, in terms of multiple choice, or sorry, partial credit, if you do it mentally, you better make sure you get it right, because you're going to get absolutely nothing for just slapping around numbers. Whereas if you try to communicate the calculus, you will be successful. Not just that, but you'll be prepared for the harder problems. This proper work would look something like this. The rule I'm using is this, and that's 2 times 10 or 20. C, how would you approach that? Or can you tell me what your answer is? Okay, so this is an example of a trap problem. This would be one where students, oh, you can do these mentally. The answer is 12. Is it 12? It is not. Okay? Students want to think, oh, it's just 2 plus the 1 to 5 integral, so it's 2 plus 10, boom, 12. Logical enough. And yet, doesn't this, by rules of integrals, mean integrate 2 from 1 to 5 and integrate f from 1 to 5? And this, that's not 2. That's 2x from 1 to 5. And so it's 8, not 2. That's 10. And so the answer to that is 8. All right, now that's an example of biting. Slow yourself down. That's a honey. What do you think on D? They go from -1 to 3, which they don't give you anything about. And f of x plus 2, what the heck is going on there? Big ideas of calculus. When you have a function within a function, you use sub it. Yeah. And so you would use sub this. You would let u equal x plus 2. du then is dx, so that's great. When x is -1, u is -1 plus 2, or 1. When x is 3, u is 3 plus 2, or 5. Now this is equivalent to the integral from 1 to 5 of f of u du. Now don't be tripped up by saying, well, that's got a u in it but not an x. It's still the same function, and whether the graph looked like this and I called this x or u, the graph doesn't change. And so it is equivalent to So sometimes you have this u subscript. What about integral from 5 to 2? How can I switch those limits so they're the right way? Yeah, negate it from 2 to 5. We know 2 to 5 is 12, I think. It's up there, 12. So, okay. It doesn't? It does. Okay. What about the function from -7 to 7 if f is odd? Then you have a negative area and a positive area. That's it. Okay. What about the, this one's a little tricky here. Okay. So the area from -5 to -2, wouldn't it match the area from 2 to 5? Yeah? So it is 12. If they wanted to really get you, they would have done -2 to -5. But it is 12. The areas do match. All right, cool. Now that required you to use one rule at a time. Gradually getting a little more difficult. Sometimes using 2 at a time. What is that first? Oh, yeah. Okay, so let me give you an example. An A. You have 2 problems. First of all, you have the -2, and second of all, you don't have the 1 to 2 region. So I would say something like -2 out front of 1 to 2 is equivalent to -2 out front. And how could you get 1 to 2? Doing these two regions together, you could go 1 to 5, take away 2 to 5. So that would be something like -2 times 10 minus 12. So that would be +4. Yeah? I feel like you should try some of these on your own, and we'll go over them together. Let's see how C uses 2 rules. It's just 1 rule, right? Not sure why I have that in the 2 rule case. Okay. D's a toughie. How are we doing? You making good headway? Those are some doozies. How's it going? Should I give you another minute or should we start talking? Another minute. This probably shouldn't have put these up here for you to. Okay. I'd rather you struggle. Okay. No. Talk to me, people. One more minute or doesn't it go? Or I was never thinking about them or just waiting to copy them down when you were. One more minute. Hey. These are good multiple choice AP exam questions. Despite the fact students feel they're easy, it's because that they don't require a lot of writing, but they are just by a substantial percent of people. Listos? Let's go with it. Okay, do you agree with 4 for the first one? How about moving out the 2 and rearranging and getting -20 for the second? The third one, doesn't feel like there's 2 rules there. It's anything from 3 to 3. It doesn't matter if it's even, odd, or anything else. It's 0. So I'm not sure why that's a 2-rule question. D was one of the hardest ones. You definitely had to split it and to integrate both parts of a sum, which you can do in a sum. So you integrate x, you eventually get 48 from the integration of x. The f you have to use sub because you have a function within a function. U is mostly easy. People do fine with the u. It's the du that you're likely to make a mistake. Du is 1/2 dx, which means dx is 2 du. So when you go to substitute, it should be f of u times 2 du, not du over 2, du times 2. Understood? Change the limits from x of 2 and 10 to u of 1 and 5. Then it's pretty clean. You have 2 out front, and the integral area you know is 10. So altogether then 68. That was a tough one. Let's go to the next row here. The first one wasn't too bad. You pull out negative to switch the limits and then do the difference between the 2 areas. Did you get +2? All right. F is a bit of a gotcha. F is odd. That doesn't mean that when you throw a 1 in front of it, it's still odd. In fact, it just ruined the whole odd idea. If you have a 1 plus, that shifts the graph up. And if you shift the graph up, that symmetry garners. Doesn't apply anymore. And so you would have to do this in a sum kind of way. You'd say, I'm going to split this into 2 integrals. Now, that's odd. So what is that going to come out to? 0. But this is more like x from -7 to 7. And so that is 7 minus -7. Your answer is 14. Okay? And last but not least, that's a u subby kind of problem because you have a function within a function. So the first thing I did was u sub. If u is 2x, then du is 2 dx, which means dx itself is du over 2. So when you go to substitute, you should have f of u times du over 2. Make sure that you're making that dx du adjustment well. That's a big idea that people tend to make mistakes in. Change the limits and you go from -5 to -2. After that, if f is even, then the region from -5 to -2 should be the same as the region from 2 to 5, yay? So it should be 1/2 of the region from 2 to 5, which is 6. Okay, cool. All right, try that last one. Multiple choice question from an AP exam in the past. See how it goes. You're gonna basically just throw all possible combinations of those two numbers out there, and you need to actually know how they should be put together well.
Good morning, Devil
What?
Jaguars.
Where'd
Please
the players
rise
go?
to the Pledge of Allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Today, 8th graders whose last names are MC to SA will be required by counseling. Speak with Mr. Norquay in the auditorium.
Junior high student council meets today in Mr. Bean's room at 7 hours. Sign up with your social studies teacher and then come on over.
Attention all future color guard members. We will be having an interest meeting for Winter Guard on Wednesday during 7th hour. Winter Guard is open for all grade levels. No experience needed. Come check out the 3A State Champion Color Guard. Bring clothes that you can see.
What'd you say?
See this class free for a pass.
A, B, C, D, or E?
Students, please come to the library to vote for the prestigious Colorado Blue Spruce Book Award. This book award does significant because the winner is chosen solely by kids. Vote. Let your choices and voices be known. Vote now.
Happy National Kindness Day from your Devil and Cheer team. Make sure to spread positivity and love this week.
Yeah.
Arizona State University.
You still have 55?
Arizona meets counseling on Wednesday, November 14th.
The key to 55 is online, so I do want 55 today.
If you would like to
I
know
don't know if you
more
have a
about
question you'd like me to put up now.
all students are invited.
Do you know, or would you like to learn how to use Power Tools? Are you creative? Do you like developing? Are you a Devlin High School student? If you answered yes to any of these questions, we'd love to have you join Station Group on the call.
Well,
Come to a meeting after school to drop off there to find out more information.
okay.
Friday, November 30th. Purchase on the General website or at the cost is $15 for the fall semester or $22 for both semesters. Don't miss out on this fun tradition.
Don't forget, Panasonic Society Canned Food Drive this week. Non-perishable items such as oatmeal, peanut butter, and canned food should be donated to your third period class. The classes must can food the party. Let's give back to the Jeffco community and help those in need.
Senior high students, the Hugh O'Brien Youth Leadership Program is to inspire and develop our global community of youth and volunteers to a life of dedication, pride, leadership, service, and innovation. You must be a sophomore and nominated by your counselor. If interested, make your
Let's put it on the graph so we can use a quiz.
2019 at the University of Denver. The deadline for guaranteed admission is December 7th. That's all your announcements. Have a great day.
Normally you do a whole circle this way, but in a half circle case, if I isolate y, it would just be the positive half, yeah? The rectangle in here then, is base times height, but in terms of coordinates, it's 2x's y and a single y height. With substitution, then you're looking to maximize this area equation. So if you use the product rule on your derivative, first stays the same, derivative second plus second stays the same. Derivative of first. That's the derivative. You with me? If we get a common denominator, it looks something like this. Negative 2x squared plus 2 times normal 9 minus x squared. Stop me if I'm going too fast. Therefore, my derivative is something like 18 minus 4x squared over root 9 minus x squared. A prime is undefined if x is plus or minus 3, but obviously that's a minimum rectangle area, that's no area at all. The max would be if a prime is 0, which is at the square root of 18 4, so the square root of 9 halves, or 3 over root 2. You'll see that this does go positive to negative there, so that is increase. So, with that, you can answer the question. I don't know if they say what are the dimensions. Okay. Have a great day. Yep, or Dan. Stop this recording, sir. I'm not walking away from you. I have 6 questions.